So I noticed this morning when kids were coming in for extra help right before the quiz, linear programming quiz, that the thing they had the most trouble with was the graphing. And so I want to do one last little graphing and then optimizing. So assume that you know how to write the equations for it, and they're in black going across the top here. I'd like you to make a sketch because that's what you're going to have to do in the test. And you'll want to use your graphing calculator to do the part where the two lines that are intersecting, where they intersect. Because otherwise, when you solve it, it'll be really hard on your graph to tell where that one little intersection spot is unless you know how to do it on your calc. All right? So I'm going to give you a minute while I pause the video and you go ahead and give that a try. Graph all of these. There'll be a feasible region. Find the corners of that feasible region. Okay, so we got it solved. This first equation is solved for y. Now I'm going to graph it. I start at the y-intercept of 4, and then I do this. That's the rise, that's the run. So it's down 2 over 3, down 2 over 3. There we go. And then it's supposed to be less than that, so I shade just underneath that. Then it's y is greater than 3 over 2x plus 2. So I start here, and I rise 3, and I run 2, and I rise 3, and run 2. So there's my next line. And that doesn't look like they crossed in a real nice place. I did that on purpose. And that's supposed to be greater than, so. And then the real world constraints, which just means that it's above this, and it's to the right of that. So there's my final answer, that little triangle, which has vertices of 0, 4. That one's easy. That one's easy. 0, 2. And the last one is right there, and you use your calculator for that one. Now, if you go into, just a second here, take this, and I need to put in my two equations on my graph, and it's 3 over 2x, which is, I'll do that on this line here, 3 over 2x plus 2, and then the other one is at negative, help me remember what that was, negative 2, was this right? Negative 2 thirds x plus 4? Oh, good. Okay, and then I go to second calculate. I'm just going to go right on to the calculate. Calculate the intersection point is number 5. And so it graphs them for me, and then it says first curve. So I put my little spider thingy on one of my lines. They could have said first line instead of first curve. I hit enter, and then second line, second curve. I hit enter, and I hit enter one more time. And there it is. The intersection point is nasty. It's 0.92 for x, and y is 3.3. So 0.92, and then about 3.4 actually. 0.92, 3.4. All right. Now, if I was going to test that in my optimization equation, if this is a profit, I can prove that this point is not it. Do you agree? Because the one right above it is going to be selling more of the y's and no more of the x's, but it's more. So it has to be more profit, assuming we get at least some profit on each one. So then it's either a choice of this one or that one. And then I can plug in 0, 4, x is 0, y is 4, and then I would get $12 profit for the top point. Then the other one is a little more icky. It's I stick in 0.92 for x, so 4 times 0.92 plus 3 times 3.4. Somebody's already got that one. What is it? Anybody get the same thing as him? Good. Then that's my winner, most profit. Okay, so that's just meant to be a quick little reminder of the harder parts, including the how to find where two lines cross. Questions or comments or whatever? Yes. Yep. Yep. Oh, good question. Yeah, this assumes that we can do partial amounts of product. And in the real world, you couldn't. And so this one, you're right, it'd be icky. On the test, I happen to know it comes out to be whole numbers, so don't worry about that. Yes, next question. Okay, check your equations on your calculator and see if your equations are the same as mine. Because if they are, you should have the same intersection point. Okay, so just look at those close. All right, you found it? Good. Next, anybody else have an issue or a question? Yes, sir. I know you have issues, but I mean, do you have a question? All right. All right, then we're done for now. We're going to take that quiz in just a minute after we grade the homework.